Today, we're going to be talking about the Earth's energy budget and heat transfer. Heat's defined as the energy that's transferred between objects that are different temperatures. When heating something, energy always transfers from the object with the highest temperature to the object with the lowest temperature. Now, heat's transferred in three ways: radiation, conduction, and convection. Have you ever warmed yourself by a campfire or felt the heat of the sun's rays on your face as you're sitting outside in the sun? That heat that travels to you directly to the earth from the sun is radiation. We sometimes call this infrared radiation. This is the same type of heat that a reptile might feel with a heat lamp above it or chicks in an incubator. You can't see infrared radiation, but you feel it as heat. This energy travels from the sun to the earth in electromagnetic waves. On the earth, we know that this radiation happens as the sun heats the land, heats the water, grass, rocks. All these things absorb heat. In the water cycle, radiation is what causes puddles to evaporate. Make sure you write some of these examples down on your paper. The sun's energy is absorbed and reflected by the earth, and we'll take a look at that in a few minutes in a graph. Conduction is the second method of heat transfer. Conduction is directly transferring heat from a substance to another substance as they're touching. Now, some solids are excellent conductors. Land is a good conductor. Metals are a good conductor. Think about kitchen cookware and what types of conductors are used. Okay. Air and water do not conduct heat very well. On Earth, conduction happens, for example, in the water cycle. The air molecules, they touch the ground, they warm up, and they rise above. In your own personal life, when you use a curling iron touching your hair, that's an example of conduction. Touching a hot stove is an example of conduction, or bacon frying in a pan. The third form of heat transfer is convection. Convection is what moves heat through the troposphere. Convection is defined as the transfer of heat by the movement of a fluid, molecules of liquids and gases. Now, convection only happens through liquids and gases. Convection is also the upward movement of warm air and downward movement of cool air. This is what forms convection currents. This is how our wind occurs. Cool air in the atmosphere sinks, takes the place of the warm air in the atmosphere that rises. Convection currents are what moves heat through our troposphere. In the atmosphere, convection currents lead to thunderstorms and cause wind. Think of some examples in your own life where you might have conduction. Remember, conduction is when you have heat transferring through movement of liquids and gases. For example, a hot air balloon is an example of conduction as that heat is rising. A fire moving upward. Think about why the upstairs in your house is always hotter during the summer, and I'm sure your basement is much cooler because heat rises. That's from convection. Radiation and convection transfer heat energy, and this is what powers the global circulation of the atmosphere and distributes heat through the oceans. Convection is what actually distributes the heat. Now, radiation, conduction, and convection work together to heat the troposphere, where our weather occurs. If you look at this picture here, the sun heats the land's surface during the day. That's heated through radiation. The land then is warmer than the air. That's conduction, because we know the air molecules are touching the land as they warm up. And air doesn't conduct heat very well, just the first few meters of the troposphere heated by conduction. But as that ground level air warms, its molecules start to move rapidly and rise. That's convection. And then eventually that cooler air sinks, forcing the warmer air to rise, which again is our convection.